In this video, you will learn how to solve rational inequalities like the one shown here. Okay, how do we solve rational inequalities? So write the inequality as a single fraction on one side and 0 on the other side. And then determine over what interval the fraction takes on positive and negative values. So we need to identify the critical numbers because these numbers will divide the number line. And the interval formed will be the possible answers to the inequality. So in this lesson, x takes many values. Okay, not only one or two like in the equation, but a set of values or all the values on a particular interval. For example, solve x plus 5 over x minus 3 is greater than 0. So what values of x will satisfy this inequality? So first step is write the inequality as a single fraction on one side and 0 on the other side. But if you will look at this is already a single fraction and this one is already 0 on the left side. I mean on the right. So we move to step number 2. Determine over what interval the fraction takes on positive and negative values. So we need to identify the critical numbers. So these critical numbers are numbers that will make the numerator 0 or the denominator 0. That means to say that will make your entire fraction 0 or undefined. So we just need to equate this numerator x plus 5 to 0 and solve for x. So add negative 5 to both sides of the equation. We will get x equals negative 5. So x equals negative 5 is one critical number. Another one is for the value of x such that x minus 3 is equal to 0. So adding 3 to both sides of the equation, we will have x equals 3. So these are the two critical numbers that divide the real number line and will also make us identify our possible intervals. So we have a negative 5 here and then 3 on the right. So we make intervals. So let's have sign analysis. So we need to identify over what intervals this fraction will take on positive and negative values. So we call that the sign analysis. So the intervals formed by these two critical numbers are negative infinity to negative 5, this part here. And then negative 5 to 3, this part here. And then 3 to infinity. We used here hollow circles or hollow circles, not solid, because for sure x equals negative 5 will not be part of the solution because this is strictly greater than 0. If x is negative 5, this whole fraction will become 0. So negative 5 is not part of the solution. Also, 3 is not part of the solution because this will make the fraction undefined. So we have here parentheses with negative 5 and then parentheses also with 3. And then we identify as test points within the intervals. Say for example from negative infinity to negative 5, let us choose negative 6. You can choose any other values. But for this case, I will choose negative 6. And we identify the signs of these expressions and the whole fraction. Okay? So, if x is negative 6, negative 6 plus 5 is negative 1. So, that's a negative. If x is negative 6, this is negative x minus 3. So, that is negative 9. So, it's also a negative. And as what you can see here, this is just obtained by dividing x plus 5 and x minus 3. So if we have a negative divided by a negative, we will have, of course, a positive answer. Let's have the second interval from -5 to 3 exclusive. So we can have 0. If x is 0, what is x plus 5? That's 0 plus 5 equals 5, and that is a positive. If x is 0, 0 minus 3 is -3. So that's a negative. And positive divided by a negative is a negative. So x plus 5 over x minus 3 is negative. And then for the last interval, identify one number in the interval. Let's say, for example, 4. 4 plus 5 is 9, so that's a positive. 4 minus 3 is 1, so that's a positive. And positive divided by a positive is positive. And how are we going to choose our answer? Since this is greater than 0, that means to say when we say greater than 0, that is positive. So we have to choose the positive answers here. Okay? So we will choose this and this, but not this one. So this one, the -infinity to -5, not this one, and also the 3 to infinity. Okay? But if this is less than 0, you have to choose this one. Okay? So, but since this is greater than 0, we have to choose the positive. So our answer here will be -infinity to -5 union 3 to infinity. So on the number line, all the numbers to the left of -5 and to the right of +3 will satisfy this inequality. So there are infinitely many solutions. Okay? Number 2, solve. X over x plus 2 is less than or equal to 0. Okay, so we need to identify the critical numbers. So x, the numerator, is 0 when x is 0. And the denominator x plus 2 is 0 when x is -2. So we have two critical numbers, -2 and 0. And then if x is -2, so we have to position it this way. -2 on the left because it's less than 0, and 0 on the right because 0 is greater than -2. And then hollow circle for -2 because -2 value of x will make this fraction undefined. So -2 is not part of the solution. And then for 0, this is a solid circle because if x is 0, this whole fraction is going to be 0, and our inequality here is less than or equal to 0. So the value of x, which is 0, will make this fraction 0, and that is equal to 0. So this 0 here is part of the solution. And then we will make our sign analysis. So what are the intervals made by these two values here? So we have here from -infinity to -2, not including -2. And then here at the middle, -2 to 0, not including -2, but including 0. And lastly here, from 0 to infinity. So these are the three possible intervals that will satisfy our given inequality. So we should identify test points. For this case, less than -2, let's choose -3. And let's solve for the value of x and x plus 2 and the quotient. Okay? So when x is -3, so this x is -3, so that's a negative. When x is -3, -3 plus 2 is -1, that's also a negative. Negative divided by a negative is positive. And then identify a value in this interval. Let's say, for example, -1. So -1 for x, so that's negative. -1 plus 2, that's +1, so positive. So negative divided by positive is negative. and then identify a number on this interval. Let's say, for example, 1. So 1 for x, so that's positive 1. And then 1 plus 2 is 3, so that is positive. And positive divided by positive is positive. And since this is less than 0 or less than or equal to 0, we have to choose the negative because if a number is negative, it is less than 0. So we have to choose this interval from -2 to 0. Okay? Please take note that -2 is not part of the solution, but 0 is part of the solution. So if we will plot that on the real number line, all the numbers greater than -2 but less than or equal to 0 can satisfy this given inequality. Let us have example number 3. Solve x plus 1 over x squared minus 6x plus 8 is greater than or equal to 0. So let's identify the critical numbers, numbers that will make this fraction 0 or undefined. This will be 0 if the numerator is 0, and x plus 1 is 0 if x is -1. So -1 is one critical number, and then the denominator is 0 if, we can factor this out, x squared minus 6x plus 8 can be factored as x minus 2 times x minus 4. And this product will be 0 if one of them is 0 or both of them are 0. So that is when x minus 2 is 0 or x minus 4 is 0. And then x minus 2 is 0 if x is 2. And x minus 4 is 0 if x is 4. So we have three critical numbers, -1, 2, and 4. So let us plot them on the number line. So that's for -1, for 2, and for 4. So we have to arrange them in order also. The lowest on the leftmost, and then going to the highest to the right. Okay. So -1 here is a solid circle. That means to say -1 is part of the solution since this is greater than or equal to 0. And a value of x equals -1 will make the numerator 0 or the entire fraction equal to 0. So this is part of the solution. 2 and 4 are hollow circles here because they're not part of the solution since these two values will make the fraction or the rational expression here undefined. So they're not part. Okay, so from these critical numbers, we will be able to make the following intervals. Here, we have -infinity to -1, including -1, so a bracket here. -1 to 2 here, not including 2. And then here, that's between 2 and 4. And here for greater than 4. So these are the 4 possible intervals for our answer. Okay, let's identify test points in each of them. So for the first interval, let's have -2. So let's identify the values of these 4 expressions. Okay, if x is -2, this is -2 plus 1, which is -1, so that's a negative. When x is -2, this is -2 minus 2, that's -4. It's also negative. And if x is -2, this is -2 minus 4, that's -6, so negative. And then this whole expression is, what will be the sign of this expression? So we have here negative times negative is positive, and then negative divided by positive is negative. Okay? So negative. How about for the second interval? We can identify 0 in this interval. 0 plus 1 is 1, so that's a positive. And then 0 minus 2 is -2, so that's a negative. 0 minus 4 is negative 4, so that's a negative. So positive, negative, negative will give you a positive, this one. Okay? Negative and negative will be positive. So positive divided by positive is positive. And then identify a value between 2 and 4. So say 3. So 3 plus 1 is 4. So that's a positive. 3 minus 2 is 1. So that's a positive. 3 minus 4 is negative 1. So that's a negative. So positive, positive, and negative will give you a negative answer. Okay? And then lastly, for the interval 4 to infinity, we have 5. So 5 plus 1 is 6, so that's positive. 5 minus 2 is 3, so that's a positive. And 5 minus 4 is 1, so that's a positive. So we have here a positive answer also. But since this inequality is greater than, we have to choose the positive answers. So we have to choose this and this one. So we will have the answer this interval and this interval for our answer. Or if you want to plot that there, that's from greater than or equal to negative 1 but less than 2 or greater than 4. Okay. So here we have this answer. X can be any number greater than or equal to negative 1 but less than 2 or greater than 4. Example number 4. Solve 3x plus 2 over x minus 4 is less than 1. So as what you can see, this is not yet 0 here, so we have to make this 0. So what are we going to do? Okay, we will transfer 1 to the left side. That's going to be negative 1. Or that is the same as saying by adding negative 1 to both sides of the equation, we will have 0 here. So as what this instruction says, we have to make the left side a single fraction or one side a single fraction, or on the others and on the other side 0. So we're okay with 0, but this one is not a single fraction, so let's apply the addition rules of adding fraction. So find the least common denominator. We have x minus 4. So x minus 4 divided by x minus 4, that's 1. 1 times 3x plus 2 is 3x plus 2. Minus x minus 4 divided by, this is over 1 here. This is over 1 here. So x minus 4 divided by 1 times 1 is x minus 4. Okay? And then if we simplify the numerator, we will have 3x plus 2 minus x, and then this will be plus 4. Okay, over x minus 4 is less than 0. 3x minus x can be simplified to 2x, and then 2 plus 4 is 6. Copy x minus 4 on the denominator. So this one here is just equivalent to this one. So this is already a single fraction on the left and 0 on the right. So we can already identify the critical numbers. These are numbers that will make our rational expression here 0 or undefined. So we will have 2x plus 6 equals 0 and x minus 4 equals 0. Let's solve each of them. 2x will be negative 6 here. And then dividing both sides by 2, we will have x equals negative 3. And for this one, x equals 4. So arrange them on the number line. So we have negative 3 on the left and 4 on the right. And since this is strictly less than 0 here, 2x plus 6 over x minus 4 is strictly less than 0, then we will have a hollow circle for negative 3. And of course, for 4, hollow circle, because that will make the rational expression undefined. Okay, so with those two numbers, what are the intervals that are formed? We have negative infinity to negative 3, negative 3 to 4, or 4 to infinity. Or that is all numbers less than negative 3, all numbers between negative 3 and 4, and all numbers greater than 4. So let's identify test points. Less than -3, choose -4, for example. And then identify the values of 2x plus 6, x minus 4, and their quotient, or just the sign. So 2x plus 6. 2 times -4 is -8 plus 6. That's -2, so negative. -4 minus 4 is -8, so another negative. So the quotient of two negative numbers is positive. And then identify a number between -3 and 4. Say, for example, 0. 0 plus 6 is 6, so that's a positive. 0 minus 4 is -4, so that's a negative. Positive divided by negative is negative. And then number greater than 4, let's say 6. 2 times 6 is 12 plus 6 is 18. 18 is positive. 6 minus 4 is 2. That's another positive. Positive divided by positive is positive. So what will we choose? This says less than 0. When you say less than 0, that's negative. So you have to choose the negative one. Okay? So our answer will be this one. All numbers greater than -3 but less than 4 will satisfy the given inequality. Or in interval notation, that is written this way. All numbers greater than -3 but less than 4. Or on the number line, they are found between -3 and +4. Okay, so that's it for solving rational inequalities. So after this, I prepared some practice exercises for you. So please answer, and I hope that you can answer those items after watching this video. Good luck!